let's do an example of finding the general derivative for this function, x cubed plus 2x. So I want you to recall a very specific thing beforehand, that this is the sum of cubes formula. A plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. So you really walk down the a's and walk up the b's, and it's 1, 3, 3, 1. If you remember Pascal's triangle, that comes from that as well. So what we need is f plus of x plus delta x. So that's x plus delta x cubed plus 2x plus delta x. So we need to find this out before we take the limit. Now, again, we can use the cubic formula here to get x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed plus 2x plus 2 delta x. So then what we have is this monstrosity here. So what I'm going to do is I'm going to do myself a little favor and group these with the things that have delta x and the things that don't. So what I have here is x cubed plus 2x plus delta, everything else has at least one delta x, if nothing else. So then that's going to be 3x squared plus 3x delta x plus delta x squared plus 2. So that is f of x plus delta x. And we already have f of x, so we need to find that limit. We need to find the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. So then, doing that, we can plug in this thing. We can say that's the limit as delta x approaches 0 of x cubed plus 2x plus delta x 3x squared plus 3x delta x plus delta x squared plus 2, yikes, minus, so we did that, minus the original function, x cubed plus 2x. Well, lo and behold, this cancels with that. It's almost like I did that on purpose. So that's the limit as delta x approaches 0 of delta x 3x squared plus 3x delta x plus delta x squared plus 2 all over delta x. And yet again, these are going to cancel. Again, almost like I did it on purpose. Can you believe it? Wild, wild stuff. So that's the limit as delta x approaches 0 of 3x squared plus 3x delta x plus delta x squared plus 2. Now what we find is that this is a kind of polynomial-ish function, and so we can use direct substitution with no issues, because it's not like we're going to have a domain problem. So then we have 3x squared plus 3x 0 plus 0 squared plus 2, which leaves 3x squared plus 2, which is the general derivative for x cubed plus 2x.